two different locations, switching one relay, one light. So let's try this. Switch 1 on, switch 1 off. Switch 2 on, switch 2 off. I could also go on, off, on, off, on, off, on, off. So just that simple. And again, just to show you your LED lights, indicating green for de-energized and red for energized. Two different locations controlling one relay, one light. Okay, perfect. Again, make sure that you have all your labeling, your two switches now, one relay, one light. Okay, that was exercise number 2. And we're going to do exercise number 3 next. And what I'm going to do is, first of all, we're going to start from scratch here. So I'm just going to take away the wiring that we had in place from our first lab for our first two for the Douglas system, and start from the beginning again. I will leave the connection for the feeding the transformer here. Okay, and I'm just going to take away my switch connection so we can just start from the beginning again, just to make sure that there is no confusion. Okay, perfect. So again, all I've done here is I just have power being fed only into my transformer that's going to feed power to my low voltage side of things. And again, we have 3 switches. We have relay 1 low voltage, line voltage, relay 2, relay 3, relay 4. Okay, so the next part of the Douglas system is objective 3 on page 10. And we're going to set up a Douglas system extra low voltage switch circuit where single switch controls 4 different circuits. Again, very similar to what we did with the GE system. So exercise 3 is asking us to draw a schematic with extra low voltage switch, switch 1, controlling 4 extra low voltage relays that operate 4 120 volt lamp. Connect the circuit, but use 4 different circuits on your branch. So basically, we're intending to connect up 4 different circuits coming from 4 different breakers in the real world, okay? And each relay will have a separate circuit. Okay, so I'm just going to take away my single light, and we're going to replace it with 4 different lights. And I'm just going to make a bond connection here. Okay, so 1 switch, relay 1 controls this branch, relay 2 this branch, relay 3 this branch, relay 4 this branch. And again, each one of these can simulate a whole branch of lights on different circuits coming from a panel or even different panels. These could represent different types of loads as well. They don't necessarily need to be lighting, but typically we have lighting circuits. So we're going to start again. We're going to have a single switch controlling 4 relays. We're going to start with switch connection on the low voltage side of things. So we are going to take low voltage white conductor and feed into our switch. Then what we're going to do is we're going to come out of our switch with a red conductor, switch 1 here, and feed into, actually we want to be able to feed into each one of our relays that we are paralleling the feeds into our relay 1. We're going to go from relay 1 to relay 2, and then we're going to go relay 2 to relay 3, relay 3 to relay 4. So now we have parallel fed one switch to 4 different relays. 1, 2, 3, 4. Then we're going to join the common side of our relays. I'm going to join my power supply to relay 1. Then I'm going to join relay 1 to relay 2, common side. Then I have relay 2 joined on to relay 3, and relay 3 going to relay 4. So really now we have a common connection from each one of our 4 relays all the way back to the power supply here. Okay, so our low voltage side is complete now. One switch to feed 4 relays on the control side. On the line voltage side, we are now going to mimic connecting 4 different circuits to 4 different loads. So I'm going to start with power supply and feed it into relay 1. Relay 1 will control load 1, and then load 1 will go back to identified. Okay. Then we're going to go and feed circuit number 2 into relay number 2. And then from relay 2, we are going to feed light number 2. Light number 2, take its identified back to its source. Now we're going to do load number 3. So we're going to feed the third load to the third relay. And we are going to connect relay 3 to light 3. We're going to complete light 3 circuit all the way back to its source. And then our 4th circuit, I'm going to use yellow. We're going to feed our 4th circuit with yellow to relay 4. Relay 4 will control light 4 on this wire, and then we will complete load 4 connection identified all the way back to our supply. So we have 4 different circuits here. Each one's, this is just to represent 4 different breakers, 4 different locations. And again, these could be 4 different loads. One switch controlling 4 relays. Each relay controls 1 bank of lights. Okay, so let's try this and see how this works. Turn the power on. We see that we have our green light there on our switch 1. When I hit switch 1, we now have all 4 circuits energized, and the LED indicates red that we are energized. Okay, and again, it doesn't matter where I hit the switch, that we are actually energizing, de-energizing. And what you're actually hearing is all 4 relays simultaneously activating and deactivating our circuitry. Okay, so again, with the Douglas system, you notice that there's different colors that are used on the low voltage side of things. That typically we have white, we have red, and we have blue as our 3 colors for our control side. On the line side, typically we're not concerned about those colors for our course here. What we're trying to mimic here is to be able to control 1 location, 4 different banks of lights. Make sure you complete your schematic drawings, as much information as you can put on there, your color codes for all your control side, label your switch, your relays, your loads, and label all your colors of wires to make them accurate. As a summary between the GE system and the Douglas, Your GE system uses colors on the low voltage side, which are white for your common, your blue white, which is your 24 volt power to your diode. You would have your blue wire in your GE, which is your common of latching a relay and pilot light contact. Your red on your control indicates or controls on, and your black controls off. Okay. You should be able to draw both schematic and wiring diagrams, and make sure you label all your wire colors, your loads, your switches, your relays, and even your different voltages, your low voltage and your line voltage. There are two different systems, this being the Douglas system. So you've learned about both GE, General Electric, and Douglas. We use extra low voltage for control and switching of loads from higher voltages. So we had 120 volts for each one of our GE and Douglas labs here, but we could have had voltages coming out, for example, 600 volts on the load side, and on the control side still had that extra low voltage. We have extra low voltage switches using smaller gauge conductors. In this case, they just happen to be all the same gauge, but you can see where within our systems that we are using on the low voltage side smaller conductors, on the line side thicker conductors. If this was 600 volt, these conductors would be thicker again. Now, this is very important when you're working on, for example,